The big picture of this lesson is about increasing and decreasing intervals, estimating x-intercepts, and even odd functions. So here I have just this random function graphed on the calculator. The first thing you might notice is that the window needs to be changed a little bit because you can't see what's going on here. So I'm going to change the y max a little bit. Let's just go with 20, see what that does. Okay, that gives a nice look at the graph. So you can see the graph is going uphill here, and then hits a local maximum, downhill to a local minimum, and then uphill again. So uphill from left to right means increasing. Downhill from left to right means decreasing. And then uphill again means increasing. And constant would be a horizontal line. Now if I wanted to determine the interval, let's say that it's decreasing here, I would need to find out what this local max is, what this local min is, and then the interval would be what's in between. So the way you'd find those maxes and mins is you would go to second and then trace or calculate for this function, and let's do the local maximum, so 4. And then the left bound of my interval for the maximum is going to be over here past to the left of the max, so right about there, enter. And then to the right, enter. And those arrows show the interval finding the maximum, and the max I want is in there, so enter one more time. And the x value, which is the value I'm interested for the interval, looks like it's -2 2/3. Because of the 0.6 repeating, I'm just going to say it's 2/3. Now if I want to find the minimum, it's the same process. This time I'll choose minimum. And then I'm going to move over towards that minimum. And I want to start off to the left of it, so enter right there. Then move to the right of the minimum. Enter, enter again. And this is interesting. It says -1.938 e -6, which means -0.0000193. That's a round-off error. The intention there, I think, is for the 0 to actually be at x equals 0. So the interval is open interval -2 2/3 or -8 thirds and 0. That's the decreasing interval. And the increasing interval, one of them would be open interval 0, infinity. And then the decreasing interval would be -infinity, -8 thirds. Okay, so next thing is x-intercepts. It looks like there's only one x-intercept right here. So I'm going to do second calc, and then 0, which is option 2. And then move to the left of the 0, which will put me below the x-axis. And then enter, and then move to the right. Enter, enter again. And the 0 is -4.2 roughly. So -4.2, 0, because the x-intercept is a coordinate. Okay, now let's look at even, odd, or neither. Here's an odd function. An odd function has rotational symmetry around the origin. And what that means is if you were to rotate the function 180 degrees, then you should have it look exactly the same. So 180 degrees around the origin looks exactly the same. And first thing is it has to go through the origin. But second of all, it should look symmetrical. When you rotate it, you should get the same thing. Here's an example of an even function. This one reflects over the y-axis. So if you do a mirror image here, the function should look the same. And then here's just a random function that's neither. It doesn't have any symmetry at all, rotational around the origin, or reflecting on the y-axis. So this is neither even nor odd. Okay, so that's the big picture for this lesson.